Today we're going to be looking at the fundamental principle of counting as a method for figuring out the total number of possibilities for an event or a situation. We're first going to look at a couple problems together. The first one says Nick came across the following problem. If a 4-digit number is randomly selected from all of the 4-digit numbers that can use the digits 1 through 7, with repeated digits allowed, meaning you can use the same number more than once, what is the probability that the selected number is 2,763? Nick knew that he had to figure out how many numbers were possible in order to know the size of his sample space. The first thing he started to do was to make a list. After the first few, he gave up. What is the difficulty in trying to create the list? Well, if I'm going to create the list, it's going to look something like this. 1, 1, 1, 1, 1, 1, 1, 2, 1, 1, 2, 1, 1, 1, 2. And that's just using like twos. It's going to get way too big, way too fast. It's not something I want to do. Next, he started a tree diagram. And it says, what problem did he encounter with a tree? Well, let's take a look at what a tree diagram would look like. I have 7 choices for my first number. 1, 2, 3, 4, 5, 6, 7. Okay, and then for each of these numbers afterwards, I would have 7 more choices. So I would have the numbers 1 through 7 coming off of 1 and 2 and 3. And then I would have another layer below that would have 7 off of each of those. It's going to get way too cumbersome. It's going to be too big. So that's not really a good option there either. What I need to do is to come up with a shortcut strategy for organizing this problem. Otherwise, Nick just thought he was going to be up all night doing it. So he asked himself, how many decisions about the digits do I need to make? Well, it turns out he needs to make 4 decisions. 1 for the first digit, the second, the third, and the fourth. His next question is, how many choices do I have for each decision? Well, I have 7 choices for each decision because that's how many possible digits I can choose from. We're going to use a decision chart as a tool to solve. So for my decision chart, I kind of lay out these 4 slots here, if you will, for each of the digits that I need to choose. And then I put how many choices I have for each digit in each slot. And then I just multiply them together. So I'm going to take 7 times 7 times 7 times 7. And there's 2,401 4-digit numbers. So going back to the original question, what is the probability that the randomly selected number will be 2,763? That's going to be 1 out of 2,401. Okay. How many 4-digit numbers could you make out of the same digits if you could not use them more than once? So I would make my decision chart again. I would have 7 choices for my first decision, but because I cannot use numbers more than once, I would only have 6, then 5, then 4. So that leaves me with 840 possibilities. The previous problem had 2,401 because I could reuse some numbers. I had many more choices. The basis for a decision chart is called the fundamental principle of counting, and this just comes from your math notes from your text. The fundamental principle of counting is a method for counting the number of outcomes. Okay. Oftentimes where order matters, but if the first event has M outcomes and the second event has N outcomes after the first one, then the total number of outcomes for event A followed by event B is just M times N. So I'm going to make my decision chart with my first, my second, my third decision. Then I'm going to multiply the choices that I have for each of those decisions together to get my final answer. I'm going to do a couple more examples here for you. A game contains 9 discs, each with the numbers 1, 2, 3, 4, 5, 6, 7, 8, or 9. How many different 3-digit numbers can be formed by choosing any of the 3 discs without replacing them? So I have how many numbers for my first digit, my second, and my third. Well, I have 9 choices for my first one. And then I'm not putting the discs back, so then I have 8 and 7. 9 times 8 times 7, I have 504 choices. Okay, part B says a new lotto game called Quick Spin has 3 wheels, each with the numbers 1 through 9. Each wheel is spun once, and the number the arrow points to are recorded in order. So I have 9 choices for my first number. It's a second wheel. There's still 9 choices for my second number, and the third wheel still has 9 choices for my third number. That answer gives me 729 possible 3-digit numbers. Okay, we'll get one more application of this. Marcos is selecting classes for next year. He plans to take the following 6 classes: English, Physics, Government, Pre-Calc, Spanish, and Journalism. His school is a 6-period day, so he has one of these classes each period. How many different schedules are possible? So I have 6 blanks, one for each period of the day. For first period, he has 6 choices. Since you're not going to take the same class second period that you took first period, he only has 5 choices for that one. Then 4, 3, 2, 1. And when I multiply that out, I get 720 different schedule possibilities. But we want to know how many schedules are possible with first period pre-calculus. So that locks down this period. I want just one choice here. I want pre-calc. If I have pre-calculus first period, then I only have 5 choices. Then 4, 3, 2, 1. When I multiply those together, I get 120. And that's the number of possible schedules that have first period pre-calculus. Part C says, what is the probability that Marcos will get first period pre-calculus? Well, it's 120 out of 720, which simplifies to 1 out of 6, which makes sense. If there's 6 classes and 6 periods, it makes sense that he has a 1 out of 6 chance of getting pre-calculus first period. Part D is a little bit different. It says, what is the probability that Marcos will get both first period pre-calculus and second period physics? So again, I'm going to figure out how many of those schedules have this combination, and then we'll divide it by that 720. Okay, so if I have one schedule, I want pre-calc first, and then one choice because I want physics second. Then I have 4 choices for my third block, then 3, 2, 1. So that gives me 4 times 3, 24 different schedules that meet this criteria. So I would take 24 divided by that total of 720. I think that's what it was. Yep, 720. That would be the probability that we would get both first period pre-calculus and second period physics. That reduces to 1/30. Okay, so it's just a general overview of some practice problems using the fundamental principle of counting. What's really helpful for you as you do these problems is to make this decision chart. It doesn't take much time to just put in the blanks and the multiplication sign in between, but it can really help organize your thinking and help you solve those problems.